We're going to move on from naming formulas to writing the actual chemical formulas now, after being given the name. So here we have magnesium chloride, and I've already pulled the relevant information from the periodic table here for magnesium and chlorine. Note that in the chemical name we have chloride and not chlorine, so it's already had that modification to the end of the word that we saw in our other questions where we were writing the chemical names. So let's get right to it. First thing is, let's write down the symbols for magnesium and chloride. Magnesium is Mg and chloride is Cl. On these symbols, I'm also going to note the charges. So from the periodic table information I have at the side there, we know that magnesium has a charge of 2 positive and chlorine has a charge of -1. If I were to write down the answer as MgCl, that would actually be incorrect. So that is the wrong answer right there. Wrong. Instead, what we're aiming to do is balance the charges. And by the charges, I'm talking about the 2 plus and the minus that are attached to the magnesium and chlorine symbols there. We need to make sure that there's the same number of positive charges as there are negative charges. Right now, magnesium has the 2 plus negative charge and chlorine has -1. So what I'm going to do is create another Cl, chlorine, with its negative charge there. So magnesium now has 2 positive charges and chlorine has 2 negative charges. The charges are now balanced, and this is how much of each ion we're going to need for our final answer. The final answer of this will be MgCl2. We needed 1 magnesium and 2 chlorines. Final answer. Let's try another question. Calcium oxide. From the periodic table entries, we know that calcium is Ca with a 2 plus charge, and oxide or oxygen is O with a 2 minus charge. These charges are already balanced. We don't need to add any extra calciums or oxygens, so our final answer will be CaO. We only needed 1 calcium and 1 oxygen for this. In this question, we'll start using the Roman numerals for the multivalent metals, the ones with multiple charges. Here I have manganese, Mn, and sulfide, also known as sulfur, S. The sulfur we know has a 2 minus charge, but the manganese has multiple charges, 2 plus, 3 plus, and 4 plus. The Roman numeral is what will tell us which charge we are supposed to use. The 3 in the center there tells us that we are using the manganese with a 3 plus charge. From here, it's the same as the other questions. Manganese has 3 positive charges right now. Sulfur has 2 minus charges. So I will add an extra sulfur to try to bring up the number of negative charges. That will bring us to 4 minus charges, while manganese has 3 plus charges. We've overshot with the negative charges, so I'll add another manganese with its 3 plus charge. We're now at 6 total positive charges and 4 total negative charges. I'll add another sulfur if it's 2 negative. Now we are at 6 minus on the sulfurs and 6 positive on the manganese. These are now balanced, so our final answer will be Mn2S3. Mn2S3, manganese 3 sulfide. For iron 2 oxide, again, we check the periodic table for the symbols. So iron is Fe and oxide is O. Oxide has a 2 negative charge, And the iron, the Roman numeral tells us that it has a 2 plus charge. The two charges are the same number, they're balanced, so our final answer will be FeO. I'm going to go a little further on this. Let's say that we were using, or that we were trying to write the formula for iron 3 oxide instead. We're using the 3 plus charge instead of the 2 plus. So Fe with a 3 plus, and oxygen has the 2 minus charge. Charges are not balanced, so I'm going to have to add an extra oxygen with its 2 minus. That brings us to 4 negative and 3 positive. I'll add another iron to bring up the number of positive charges. Still not balanced, but there's more positive than negative, so I'm going to add another oxygen with its negative. We're now at 6 positive on the iron and 6 negative on the oxygen. The charges are now balanced, so our final answer for iron 3 oxide is Fe2O3. So make sure you are paying attention to the Roman numerals, as it can result in a different final answer, even if they are using the same elements. Iron 2 oxide is written differently from iron 3 oxide. Still the same type of question, except now I'm using one of the polyatomic ions that were mentioned in another video. Ammonium oxide. Same process, NH4 with a positive charge for ammonium, and oxygen, O, with a 2 minus charge. So I'll add another ammonium ion to bring the number of positives up to match the 2 from the oxygen. So I've got 2 positives and 2 negatives. So when writing this out, I'm going to write this as NH4 with brackets around it and a 2 afterwards, followed by an O. It's important to note that if you have more than one of a polyatomic ion, you have to put brackets around it when you're writing out its formula. Otherwise, you could get something like this. NH4 with that 2 on the end. That could be misread as 1 nitrogen, 1 N, and 42 hydrogens, 42 H's, which it is not. There's supposed to be 2 of those NH4 groups, not 42 hydrogens. So make sure you are putting those brackets around the polyatomic ions to avoid that kind of confusion. One final example that includes a bit of everything. We have copper, which is Cu, and the Roman numeral tells me that this has a positive charge. And then we have carbonate, which is CO3, and that comes with a 2 negative charge. Now we have more negatives than we do positives, so let's bring up the number of positives. Make another copy of the copper. And now the charges have balanced out. We have 2 positives and 2 negatives. So our final answer is Cu2CO3. Or not calcium, copper carbonate.